G'day chemistry students. In this video we're going to be looking at dot point 4.2.1 and 2 again. This is Hess's Law part 2, and in this video we're going to be looking at some further applications and concepts surrounding Hess and his law. So first off, what I want to talk about is the enthalpy of formation. And essentially the enthalpy of formation is the energy required to form a compound from its particular element. So in this diagram here, what we can see is there are some enthalpy changes in which there is a loss of energy as elements like carbon, hydrogen, and oxygen form more complex products. So in this first example here, we have an enthalpy of formation where we are forming this molecule here, which is C3H8. So note that you've got your 3 carbons, which is just solid carbon, reacting with hydrogen gas to then form C3H8. And in the process, it's an exothermic process, so the reactants are losing energy that they once had. Similar, we also have this enthalpy of formation here for a reaction in which carbon dioxide and water is formed. And so what we can do using these two numbers, these two enthalpies of formation, is we can combine them together to actually figure out what the enthalpy of combustion was if we were to burn this fuel here. So this guy would be the fuel, to be reacting with oxygen in a combustion reaction and forming the products of carbon dioxide and water. And by combining these two enthalpies of formation, you can actually find out what the enthalpy of that reaction is. We're going to do that similar process in a calculation in a moment. Something to keep in mind is that enthalpy of formation is a standardized value. It's something that scientists have gone to the trouble of testing rigorously. Generally speaking, to find an enthalpy of formation, you'd have to be doing multiple tests. Multiple people would have to repeat the process and the experiment until you're able to land on a set enthalpy of formation that then becomes standard or literature data. So you won't find any of these enthalpy of formation on a data sheet. You also don't have to memorize the enthalpy of formation for any substance. If you're going to do a question that requires you to use enthalpy of formation, you'll be given it in the question itself. So let's go have a look at a practice question to see how that will work. So for this video's practice question, we're going to be looking at trying to find the enthalpy of the process for photosynthesis. And we've been given enthalpies for formation for the relevant reactants and products. Now, what we're going to need to do to try and find the enthalpy of formation is first write out or identify all given equations. That's step number 1. So what I'm going to be doing first is writing out those 3 equations, and I'm going to label them reaction 1, 2, and 3, and in them I'm going to write down the formation equations for water, carbon dioxide, and glucose. So for equation 1, we have hydrogen gas reacting with oxygen gas to form liquid water. And what we should be able to see is that the equation is not necessarily balanced. The hydrogen is balanced, but the oxygen is not. So we're going to have to put a coefficient of half in front of the oxygen there to ensure that we're reacting in the correct ratios. For the next one, we're looking at the formation of carbon dioxide. So that will be formed by carbon, which naturally exists as solid, and that's going to be reacting with oxygen gas as well, forming carbon dioxide gas. And what we should be able to see there is that the ratios of carbon to oxygen on both sides are appropriate and correct, so that's completely fine. We can move forward. With the next reaction, we're forming glucose, which is a solid. Its formula is C6H12O6, and it's a solid. So when we're writing down the reactants on the other side, again, we've got carbon that's a solid, reacting with hydrogen gas, reacting with oxygen gas. So to make sure that everything is equal and balanced, there needs to be 6 carbons, 6 hydrogen molecules, and 3 oxygen molecules. And what I'll note is that for equation 1, 2, and 3, all of the elemental components are on the reactant side. The products is the compound that has been formed. What we need to do next is write down equation 4, which will be the equation that we don't know the enthalpy for. So we don't know the enthalpy for photosynthesis, so we need to also write out the photosynthesis equation itself. So we should know, just sort of by general knowledge, that glucose is formed by reacting carbon dioxide gas, water, and that will end up forming glucose, C6H12O6. And we also have oxygen as a gaseous byproduct. Now what we need to do next is make sure that we've got all of our equations balanced. So I'm going to do carbon first. So there's 1 carbon on this side, 6 on the other. 6 goes out the front. There are 2 hydrogens here and 12 on the other side. 6 goes out the front. Then we need to make sure that our oxygens are balanced as well. So on the reactant side, we have 12 oxygens plus 6 is 18. There's already 6 oxygens here, which means that the O2 gas must total up to 12 oxygens, meaning that I'm going to put a coefficient of 6 there. Now what we need to do for this next part, now that we've written out the equation of unknown enthalpy, is to rewrite all of the equations of formation so that all of the relevant compounds are either on the correct reactants or product side, and also to make sure that our ratios are matching, our stoichiometry is matching. So what we're going to be looking at first is the formation of water. Now what we should note is that the water in equation 4 is not on the matching side, it's on the reactant side. So what we're going to need to do in a moment is reverse the equation for formation, and that's going to have an impact on the enthalpy of formation as well. What we should also note is that equation 4 has 6 waters, whereas the formation equation only has 1. So we're also going to have to multiply the reactants and products of equation 1 by 6 so that they match up as well. Looking at equation 2, carbon dioxide is our product that we are forming, but carbon dioxide in our equation 4 again is on the opposite side. So that's going to mean that in a moment we're going to need to reverse the equation, and we're also going to have to multiply it by 6 for the same reasons that we're going to have to multiply equation 1 by 6. We also have to finish off our glucose. So the formation of glucose means that the glucose molecule is on the product side. This also matches equation 4, and we should also note that this stoichiometry is also the same. There's just both 1 mole of glucose present in equation 3 and 4. So we can just use this equation as is. There's no reason to make any changes to it. Now that we have all of that information down, we can rewrite equation 5, equation 6, and equation 7. So for equation 5, we're making adjustments to our formation of water equation. So we're going to reverse the equation and have water on the reactant side, and then have our reactant on the product side. We're going to have the same thing done for the carbon dioxide as well. And note that we have to multiply all of equation 1 by 6, and we also have to multiply all of equation 2 by 6 as well. And for equation 7, as we said, we can just use it as is, so all I'm going to be doing is rewriting that one down the bottom. It will be exactly the same as equation 3. There have been no changes required.